I hope everyone's doing well. I'm Mr. Ish. Thank you for joining me for this video where we're looking here at two basic trigonometric functions, their derivatives. When I'm looking here at the sine x, I know f of x is equal to sine x. If I were to draw it out, you know the sine curve, it's not hard. We can go here by, let's say, 0. I have here a pi over 2, a pi, and a 3 pi over 2. Lastly, we close it out with a 2 pi. I have a positive 1, I have here a minus 1. When you look here at the sine curve, sine of 0 is a 0, sine of pi is a 0, sine of 2 pi is a 0, sine of 90 pi over 2 is a positive 1, sine of 3 pi over 2 is a minus 1. You connect these and you generate a basic sine curve, but it's just a single. You can extend this now on this way, you can extend this way. If I look over here at points 0, these are my x, 0, pi over 2, pi, 3 pi over 2 and 2 pi, and I look at corresponding tangent lines, which I'll just call as tangent line slopes, TLM, tangent line slope, M for slope. If I were to look here at this point and I were to draw a tangent line to this curve, grazing it, it would look something like this. What would be the slope of this? It would be a positive 1, and I'll put it right over here. If I were to draw a tangent line right here at this point and I extend the line and I determine the slope, it would be a 0. When I look right here at this and I draw a tangent line and I graze it, I'm looking here at a slope which is equal to a minus 1. At pi, x value, it's equal to minus 1, slope of a tangent line. At 3 pi over 2, I draw a line that's horizontal. You know the slope of that is a 0. At 2 pi, when I draw a tangent line, it looks something like this. Of course, it would be touching it, but it looks something like that, and the slope here would be a positive 1, and we have that. And now all we have to do is take those x and y values and plot them out, and we don't need this graph anymore. When I plot them out using the same x and y axis values, 0, pi over 2, pi, 3 pi over 2, and I do a 2 pi, a positive 1 and a minus 1, look what happens. 0 comma 1, I have a dot over here. Pi over 2 comma 0, I do this. Pi comma minus 1, I connect it here. 3 pi over 2 comma 0, it's over here. 2 pi and a 1, it's over here. Now when I connect these using the slopes of the tangent lines at particular x values of the sine function, I have generated now a curve which looks like the cosine, because when you extend this, you know this right here is a cosine. How do you know it's cosine? Because at cosine of 0, your value is a 1. At cosine of multiples of 90s, you always have a 0. So when you're looking at the sine function and you do its derivative, your output here is always a cosine. The derivative of sine function is a cosine, and I've shown it to you graphically. Now this one is done, sine x, you know the derivative is a cosine and you remember that. Now let's look at the derivative of the cosine. This right here is your basic plot for cosine function. We have x values and tangent line slopes. We haven't done that yet, but let's draw our cosine. Cosine of 0 and cosine of pi over 2, cosine of pi minus 1, cosine 3 pi over 2 is 0, and this. You connect this and you're looking at something which looks like this, and you can connect it onwards and like this. This right here is my cosine function. And now at these particular points, let's look at tangent lines. When I draw a tangent line at 0, it's going to go across right here, horizontal line. At an x value of 0, you have a horizontal line slope which is equal to a 0. When I do pi over 2 and I draw a tangent line here, grazing this function, it looks something like this. The slope here is equal to minus 1. And you're looking here at these in terms of I estimates or rough estimates. It looks like equally steep, equally flat, slope is equal to minus 1. And I have here at a value of pi over 2, it's a minus 1. At a pi, I'm looking here across as a tangent line which is horizontal. At pi, I have here a 0. At 3 pi over 2, I'm connecting a line. And what does it look like? It's going to look like in this direction, equally flat, equally steep, but in a positive manner, positive slope. 3 pi over 2, I've generated a slope of positive 1. At 2 pi, I have a horizontal line. At 2 pi, the slope is a 0. Now we take those x values and the tangent line slopes and we generate what will be the derivative of the cosine function. This right here is my cosine function, and we'll plot it out. We were looking here at f of x is equal to cosine x. Now let's generate what will be a derivative graph. Here's 0, here's pi over 2, pi, 3 pi over 2, and 2 pi. Positive 1, minus 1. Plug those values. 0 comma 0, pi over 2 comma minus 1, pi comma 0, 3 pi over 2 comma 1, and 2 pi comma 0. When I'm plugging these in, it looks something like this. That's what it is. Now look at what the sine graph looks like. The sine graph looks something like this. What you're seeing over here is a reflection of the sine graph along the x-axis. You're looking here at a solid line. Don't look at the dashed line. That's only for perspective. When you do the derivative of the cosine x, you're getting a reflection of the sine x graph, which means you're looking here at a derivative which is minus sine x. This right here represents a reflection of your sine x across the x-axis. So we've done this. The derivative of sine x is a cosine x, but the derivative of cosine x is not a sine x, it's a minus sine x, a reflection of the sine x. And these are two derivatives you should know. Sine x derivative, cosine x derivative, minus sine x. And we do these by mapping out x values and corresponding tangent line slopes. Thank you for watching.